So if we look at my little person, we see that there's two openings that air can go into in the respiratory system. Those are the only ins and outs of air into the body. Okay, air does not enter the body anywhere else. All right, so air goes into the nasal cavity, and when a person is not physically exerting him or herself, when their breathing rate is normal, they will undoubtedly breathe in through the nose unless they are congested. Okay, and inside the nose, it's a really interesting place because the inside of the nasal cavity is lined with mucus. And I'm going to draw it green because mucus is always green. Okay, so here's our mucus. Now, the interesting thing about this, though, is that in addition to the mucus, we also have little cilia that line the inside of the nasal cavity. And they also line the nostril out here. Okay? And as air goes in, so as my purple line of air here is going to go in, we're going to see that a lot of the little microbes that are mixed into that air are going to get trapped not only in the mucus, but in the cilia as well. Okay? So that acts as a filter. The nasal cavity acts as a filter. In addition to being a filter, it also moistens and warms the air as it enters the body. So as that air goes into the nasal cavity, it's getting filtered and cleaned by the mucus and the cilia. It's getting warmed and moistened by the mucus. Okay, so that is then going to make its way down to the actual respiratory portion of its journey. It's going to get to the back of the actual nasal cavity, into the back of the throat here, and this location is known as the pharynx. Okay, your pharynx is the back of your mouth, beginning of your throat. We're assuming here, now notice how I haven't drawn the esophagus or the epiglottis. We're assuming that you're not eating anything right now and you're not swallowing anything right now. So that the epiglottis is in its open position and air is just able to pass freely. So if we assume that the epiglottis is right about, I don't know, here, okay, and we assume that that's open, the air is going to pass through, and then the next place it hits, this is where you have your vocal box, okay, or your vocal cords, also known as your larynx. Once the air passes the larynx, it's going to go into the actual chest cavity proper, because your larynx is still considered part of your throat. Okay, as is the beginning of this tube that is always open, called the trachea. Some people refer to it as the windpipe as well. And the interesting thing about the trachea is that it too has a small amount of cilia and mucus that line it. So that if somebody is breathing in through their mouth, we are seeing the same benefits that you would see as somebody breathing in through their nasal cavity, but air that comes in through the mouth is not as filtered, it is not as moist, and it is not as warm as that extra time that it's spent in the human body when it's inhaled through the nasal cavity. The interesting thing about the trachea is that it is not at all like the esophagus. The esophagus is an extendable, flexible, bendable tube. The trachea is not a bendable tube. It is structurally much stronger than the actual esophagus. If you want to kind of differentiate between the two, the esophagus is a straw, whereas the trachea would be a garden hose in terms of their structural differences. The trachea is actually made of cartilage. Okay, and we know that cartilage is stronger than soft tissue like smooth muscle and skin. Okay, and that's important because we never want the trachea to close. Trachea closes, you stop breathing, and you don't last much longer than that. Okay, so the trachea always stays open. So once the air hits the bottom of the trachea, it gets divided into two separate tunnels or tubes. Okay, and those tubes are called bronchi. Okay, one bronchus, two bronchi. All right, and those bronchi direct the air right into the actual lungs. So once the air gets into the actual bronchi, it gets funneled into even smaller little tubes called bronchioles. All right? It still hasn't made its way into our bloodstream or anything yet. It's still getting to all of the extremities of both lungs. So I've only drawn this in one lung, but this is happening in both lungs. Okay, so these guys right here are called your bronchioles, and you have many of them. So when someone is suffering from bronchitis, they're suffering from inflammation, so a mucus buildup, because all of these are minutely lined with mucus, naturally. If you have something like bronchitis, you are suffering from a buildup of mucus in your bronchi and bronchioles. Okay? So it usually makes you want to have to cough. It makes it harder to breathe. There might be wheezing. You might have a bacterial infection. And that might cause bronchitis because it's closing off your bronchi and your bronchioles. It's making air really hard to pass through there. Okay? Now, in terms of how we actually get air from our lungs to our blood vessels, this happens at the ends of all of the bronchioles, into these little air sacs called alveoli. One alveolus, many alveoli. Individually, one of these little sacs is called an alveolus, but together they're all called alveoli. Now, going back to my passage of air, my air comes in, if we look up at the top, the air comes into the nasal cavity, it gets filtered. It then goes down to the back of the pharynx, where it merges with the throat, okay, or the pharynx, and then once it passes the epiglottis, which is naturally open, it goes in and passes through the larynx, all right? It hits the trachea, more filtration occurs. Once it gets to the trachea, it then goes into either your right bronchi or your left. Okay, and although we've only drawn it on one side here, the exact same thing is occurring, okay, in both lungs. As that air comes down, it then makes its way through the trachea. It divides one of two ways here, okay, and it goes basically into each of these bronchioles, where it gets into the actual alveoli. And the alveoli are the site of gas exchange. What gas does the body need? What type of gas do we need? We need oxygen. What type of gas do we not need? What is toxic to us? Carbon dioxide. So the exchange of oxygen and carbon dioxide occurs at the actual alveoli. Once we actually exhale, and we know how the intercostal muscles work and the diaphragm pushes up, makes the lungs smaller, which forces the air to just retrace its steps. It's going to go from the alveoli to the bronchioles, from the bronchioles to the bronchi, back to the trachea, past the larynx, If you're somebody like me and you're speaking right now, you're going to make sound with the air you're exhaling. Okay, then it goes up through the actual pharynx, and usually you exhale through your mouth. Okay? So if we look at the air we inhale, the vast majority of the air that you're inhaling has about 21% oxygen. That's a lot of oxygen. It's got a very small amount of carbon dioxide, okay, in terms if we're making ratios. Now, what else, how is inhaled air different from air that you exhale? Is it dirtier or cleaner than exhaled air? It's going to be cleaner because you filtered it. So inhaled air is dirtier because you haven't filtered it yet. Okay? What about the moisture level? Is it drier or more moist? Dry. It is going to be drier because you have not moistened it yet. And what about its temperature? Is it going to be cooler or warmer? Yes, cooler. Okay, so we know that inhaled air is dirtier, it hasn't been filtered yet, it's colder because it hasn't been warmed by the mucus, and it's drier because it hasn't been moistened by the mucus. So as you inhale this air, it goes through the pathway that we just did in the last slide, and oxygen and carbon dioxide exchange occur, which we'll talk about later. And then exhaled air has a very different mixture, okay? But what's surprising is when you exhale, there's still a very large amount of oxygen in the air you exhale. So when we look at exhaled air, we see that there's still a high concentration of oxygen. That's why things like artificial respiration in CPR are as successful as they are. Because if you're blowing the exhaled air from your lungs into somebody else's mouth and you've blocked off their nose, that air is being forced into their lungs. There's still a high enough concentration of oxygen there that those cells in that person's body will get that oxygen. That gas exchange will still occur. Okay, that's why we don't say, well, no, if I give this person artificial respiration, I'm just going to be blowing carbon dioxide into their mouth. Yeah, you'll be blowing some, but there's still a high enough concentration of oxygen there that they're going to get the oxygen they need. Okay? So you need to know the difference between inhaled air and exhaled air. And when we talk about the differences, we're not just talking about the actual concentrations of the gases, we're also talking about the states of the air. And if you want to check about moisture and warmth, on a cold day, go outside and you can see the actual air that you're exhaling. You can see the mist that it creates because of the water vapor and the actual temperature of the air.